Hi, how are you today? So I'm Muhammad Yusuf. Okay, today I would like to share the knowledge about the modeling and slope stability analysis of soil slope using Plaxis 2D. Alright, so today we are going to design very simple slope with the gradient of 45 degree and with only two layers of soil. And if you see here, the length of the slope is 40 meter, with the height of the slope is 40 meters, and this for the upper layer we have the soil properties. So if you see here, this is the properties of the soil. This properties is related to the more column model. Okay, and we have also the properties for soil layer number 2. And before you create or you model in Plaxis software, first you have to determine what is the coordinate of your model. So for this example, the coordinate start from 0, 0 to 40, 0, 44, 34, 29, 0, 9, 0, 14, and 0, 14. And then sometimes we have to sketch the groundwater table. Okay, so you have to know the coordinate, okay, for the groundwater table. So how to model the slope in Plaxis 2D? Okay, let's open the Plaxis 2D. Okay, if you open the Plaxis 2D, so we have to name the title, okay, for our file. Okay, let's say the title for the file is slope stability of soil slope, right? And then we go to the model. We use the plane strain, okay, 15 nodal, and you can use the default unit. And important here is how to set the contour for our sketching, right? If we refer to the model, okay, so this is our model. So the length of our model is 40 meters. So this is the maximum, okay? The minimum is 0, maximum is 14 for the x-axis. And for the y-axis, the minimum is 0 and maximum is 14. So we have to set up in the contour x minimum 0, x maximum is 40, while for the y-axis, y minimum is 0 and y max is 40 meter. Okay, and then click OK, and you can start sketch your model. Referring to this coordinate, okay, you can start sketch the model in Plaxis 2D. Now we have to choose the structures. Okay, choose the create soil polygon. So we will start from 0, 0. Okay, so you can see the coordinate here. Okay, as your reference, and we go to 40, 0. Okay, you see the coordinate 40, 0, and then you click to 44, and you click to 30. Okay, 34, then 29, where's 29, and you go here 09. Click. Yes, this is a lower layer of soil. Then you have to create the upper layer soil. So you click here, you click to 0, 14, you click to 10, 14, and the last point is 29. Click here, done. So now your model is already completed. Okay, now you have to create a soil, okay, for each layer. Okay, you go to the material sets and you click new, then you name as, okay, the first layer is upper layer. Okay, in this case, okay, you can use the more column model, and the drainage is, we use drain because I assume the long-term stability of the slope. And then you can change also the color. Okay, let's change the color to green. Okay, green. And then, okay, you can minimize this. Okay, and then click. Okay, and then the unsaturated unit weight is, okay, let's say 17. And then this is saturated unit weight is 18. Then you go to the parameters, and the Young modulus is 15 megapascal. The Poisson ratio is 0.225. And then the cohesion is 4 kilonewton per square meter. The friction angle is 20 degree, and dilation angle is 0. And now you can click OK. So you create the upper layer properties. Now you have to create the lower layer properties. Okay, so this is, we name as lower layer, and we use the more color model, use drain, and you can change the color. Okay, let's change the color to pink color. Okay, and then, okay, then click. Okay, then you go to set the unit weight. Okay, 18, and then the saturated unit weight is 19, and the parameters, the Young modulus is let's say 20 megapascal, and then the Poisson ratio is 0.23, and then the cohesion is 8 kilonewton per square meter, and the friction angle is 25. Then you click OK. Now you have to assign your material to each layer. So if you click here, this is the lower layer, so you just click and then drag to the respective layer, and the upper layer you should drag to this upper layer. Then you click OK. Right, so if you click here, it's done. Right. Okay, next. Okay, you have to save the file. Okay, name as slope stability of soil slope 1, for example. Okay, you click save. Okay, then we have to mesh. Okay, then you click the generate mesh. Okay, you can select here the element of the mesh. Either you can choose very coarse, medium, fine, or very fine. But in this case, medium should be okay. Then you click OK. Okay, so you want to see the mesh of your model, right? So you click here, view mesh. Then the meshing, okay, of your model will be appear. Okay, so this is the mesh, okay, for your model. And then close. We go to the next stage. Okay, and then the flow condition. If you want to create the flow condition, yes, you can create the flow condition, right? Okay, in this case, okay, for example, I want to model the rainfall infiltration, okay, into this slope. So how to model the infiltration? So okay, if you click here, okay, okay, you click the top boundary, and at the same time you press the control button. You can click also this line. You can also click this line. So you click this line. Okay, so why you click this line? Because this is the location where the rainfall will be infiltrate, right? So when you refer to the selection explorer, there is a behavior here, so you have to click infiltration. Okay, so the infiltration here is Q, so you have to set up the infiltration rate. Okay, for example, the infiltration rate is 0.01, for example 0.01 meter per day. Okay, and then you just click okay. See, all right, so click save, and then we go to the stage construction, and you click the initial phase, double click the initial phase. Okay, so in this case, for the calculation type, you have to choose the gravity loading because our model is not horizontal. Okay, our model is non-horizontal layers, so you have to select the gravity loading. Okay, and then you have to click OK. Okay, when you click the initial phase, okay, you can see here it shows an inactive model, right? So what you have to do, you just click here, right click, and you have to activate this layer, and you have to calculate this layer as well. Okay, so you see there are two layers here in the initial phase, and then after that you have to add another phase. Okay, we double click the phase 1, and you have to name as displacement, right? You name as displacement, and then okay, you can use the plastic calculation. Okay, plastic calculation. Okay, if you are not constitution not considered. Okay, but if you want to analyze the stability of the soil slope, for example, so you have to do the consolidation calculation. Okay, so in this case, okay, we use the plastic calculation. Okay, and then just click OK. Right, and then at the same time you have to select the initial phase because you want to calculate you have to calculate the factor safety for the slope. So you click here and add phase. So if you click the phase 2, and then you name it as factor safety FS, and then the calculation type should be safety. Okay, because you want to calculate the factor safety of the slope. Okay, then you click OK. Done. All right. So if you see here, right, so this is the infiltration, right? We set to 0.01, right? Okay. Okay, so now you can save, and then you can calculate. Okay, you just ignore the feedback and calculate. Okay, because you don't need to select the node. Okay, and then it will calculate, I think less than 2 minutes, less than 1 minute. Okay, depending on the capacity of your computer or laptop. Okay, because this is a very simple model, so maybe it takes less than 1 minute. Okay. Okay, now okay, we see the result. Okay, you want to see the result. Okay, you go here, view the result. And then, yeah, you see here, okay, this is the deformation, okay, of the soil here. So if you want to see more detail, okay, you go to deformation, total displacement, and you click here. Alright, so this is the slip circle, okay, the potential of the slope failure. But okay, actually, what is the factor of safety of this slope? Okay, what is the factor of safety of this slope? Okay, if you refer to the total displacement, actually the total displacement here is very high. Okay, in the safety analysis you cannot use the displacement because it is wrong. Okay, if you want to know the displacement of this slope, you can choose the phase number 2, okay, phase 2, and then actually this is the exact value for the displacement, 0.4525 times 10 power minus 3. Okay, so this is the displacement or deformation of the slope, right? This is the correct value of the displacement. Okay, so you go to safety analysis, right? But what is the factor of safety here? So if you want to know the factor of safety in Plaxis 2D, so you have to click the curve manager. Okay, just click curve manager and you create new. Okay, and for the x-axis you choose project, step, it's okay. And for the y-axis you use project and you click the multiplier and you click the MSF, summation of MSF, okay, represent the factor of safety. Okay, you click here and you click. Alright, so if you see here, okay, so the value of the Fs, okay, see, this is the value of SS equal to 1.35, approximately 1.35. okay, if you want to know the exact value, you just click table, then you can see, okay, the value here is 1.35, 1.352, okay, let's say 1.35, okay, 1.35. okay, so this is the factor of safety, okay, 1.35. so you just close this and go here. No, alright, but you can also place the value of the factor safety in this diagram. So how to do that? So you click add label annotation. Okay, you click here and you can click anywhere here. You just double click and then Fs equal to 1.35. okay, and then you click OK. It shows you that Fs equal to 1.35. But if you refer to the total displacement, it's not correct. Alright, so I think it's done. Okay, thank you for watching. Hope you enjoy it. Thank you very much. Bye.